Hey, welcome back. So we are continuing the lesson 3.6, converting measures. We went over example 1, where we were converting within the same system, meaning either customary to customary or metric to metric. And now we're moving on to an example where we are going to go between systems. So that means either customary to metric or metric to customary. Something to notice about this reference sheet when we go to convert between systems is that you'll notice certain things are repeated. For example, if you were going from feet to meters is actually on here twice. So I can put 1 foot is 3/10 of a meter, but I also notice that 1 meter is 3 and 28 hundredths feet. Okay, so we have to think about, am I going from metric to customary or customary to metric, and which one do I want to choose when working with multiplying by a conversion factor or using a ratio table? And I will show you what that means. You can't go wrong though. If you pick one or the other, you will get the same. You'll get the same conversion. So let's take a look at example 2, where we are converting measures between systems. So this is example 2, converting between systems. That's going to be metric to customary or customary to metric. And if you want to leave yourself a little note, metric. Okay, remember you can always pause this video if you need more time copying notes down. Okay, so our example to convert between systems is to convert 10 meters to feet. Right, so my final answer will be blank feet. 10 meters is what in feet? So our first strategy was to use a ratio table. And I'm going to follow the same procedure I did when I was converting within the same system. First thing I ask myself is, what am I comparing? I'm comparing meters and feet. I do like to give myself a little bit of a note on the side that meters is metric and feet is customary. So that means I'm looking for a conversion from from metric to customary. Meters to feet, metric to customary. So I look on my reference sheet. Okay, here's customary to metric. I'm going to go with metric to customary, right? M to C, M to C. So again, I need meters to feet. Okay, well, 1 meter is about, remember that squiggly line means approximately. 1 meter is approximately 3 and 28 hundredths square feet, or feet, I'm sorry. So I have 1 meter, and this is my conversion factor, right? 1 meter is approximately 3 and 28 hundredths feet. Okay, well, I have 10 meters. What will that be in feet? I'll let my ratio table do the work. 1 times 10 is 10, and 3 and 28 hundredths times 10. I know when I multiply by a power of 10, my decimal moves. So it gets greater by a power of 10. So instead of 3 and 28 hundredths, I have 32 and 8 tenths. So 10 meters, that's the abbreviation for meters, equals 32 and 8/10 feet. And actually, I want to go back and make sure that these are squiggly lines. It's approximately. When we're going between systems, it's not an exact conversion, but we can get pretty close. Okay, my next strategy would be to multiply and cancel, multiply by a conversion factor. This is where I'm setting it up like more like a fraction. Okay, and once you get comfortable with one or the other of these strategies, feel free to run with that. Right now we're just learning, so it's whatever you're comfortable with. So I start with my given information. I have 10 meters, make it a fraction, times, now I'm looking for that conversion factor. These strategies kind of like mirror each other, right? So that conversion factor I need, well, I want to be able to cancel meters. I know I'm going from meters to feet. Okay, meters to feet. Well, I'm going to use that same conversion factor. 1 meter is the same as 3 and 28/100 feet. My units cancel, and I'm left with feet. 10 times 3 and 28/100, right, times 10 is 32 and 8/10 feet. I'm left with feet. So here I go again. I get the same answer. So 10 meters is approximately 32 and 8/10 feet. Both methods get me the same answer. Okay, so I do want to address if I had used the other conversion factor, right? Because remember I said it's listed twice. You don't have to write this down, but I do want to show you what happens. Okay, so just FYI, don't have to write this, right? You're not writing this. I could have had meters, feet, and the conversion factor I could have chosen would have been 1 foot is 3/10 meters, about approximately. Well, I was given 10 meters. If I had set up my ratio table like this, I would kind of get myself a little bit stuck because I don't know a number times 3/10 that gets me 10. So I would have to go over to my calculator and do the division, right? So 10, here, let's be in my calculator, 10 divided by 3/10, whoa, gives me 33 and 3/10 repeating. So 10 meters is approximately 33 and 3/10 meters. That's really close to the answer that I got before. You will notice that you or your classmate or you or Mrs. Collins and I get a different answer. But if it's within a 10th or a 100th, like these are very, very close, then you're good. It just depends on what direction you're going. Metric to customary, customary to metric. The conversions aren't super pretty and clean. So you're just going to get a different answer. The reason I would go and choose the other customary to metric, right? Metric to customary is I don't have to do this messy division work. When I chose the other way, metric to customary, I just followed what I had, metric to customary. I was multiplying. But really, either way is completely fine, right? I give myself little notes, metric to customary, and that's the conversion factor I look for. Okay, you may also come across converting rates. This is example 3. Oops. In these cases, when we convert rates, we're given a rate that has 2 units of measure, but only one of them are changing. Sometimes both change. Those are more the higher order thinking questions. So for example, we might be asked to convert 300 feet per minute to yards per minute. So notice here that feet are being converted to yards. The minutes are staying the same. So that tells me it's kind of like my other problems where it was asking me what is 300 feet in yards. The minutes are staying the same, but notice it's a rate this time because I'm comparing feet and minutes. I just want now my answer to be in yards and minutes. So keep in mind that if you're starting to see a lot of units here, it might be a rate, and you really have to zoom in on what units are actually being converted. Okay, the minutes are staying the same. I just want my length, my distance to be a different unit. Okay, so again, we can use both of these strategies. If I use a ratio table, I'm converting feet to yards. And I notice that that is customary to customary. Customary to customary. Well, customary to customary, feet to yards. Well, 1 foot is 12 inches. Now, how about 1 yard is 3 feet? 1 yard is 3 feet. Always making sure that I'm copying it in the right section of my ratio table. All right, well, I have 300 feet. Now the ratio table does the work. 3 times 100 is 300. The trickiest part here is to make sure that you include the rate in your answer. That's why I always write out my answer at the end. So 300 feet per minute equals 100, my new unit, yards per minute. Feet to yards, feet to yards. Okay, I can also use my multiplying method. By my conversion factor. So I write my given information, 300, but notice how I write it, feet per minute. I write it as a fraction. It's 300 feet per 1 minute times my conversion factor. Well, I want feet to be gone, so I need feet in my denominator. Feet, feet, feet to yards. I know that there are 3 feet in 1 yard. Feet cancel, and I am left with yards per minute. I can't forget now. Remember, it's a rate. I have 2 units. So that leaves me with 300 times 1, which is 300. And 1 times 3, which is 3. Well, I know 300 divided by 3 is 100. So this is yards per minute. So I'm back to my same answer, 300 feet per minute equals 100 yards per minute. Both strategies work.